Hey, glad you're here. I'm Ian over at Kavu Media Group, and I'm going to walk you through this. Quick bit of context before we dig in. I've been using LLM tools for a couple of years now. Started with ChatGPT, then Gemini, as well as SuperGrok. Honestly, I still use all of them daily. But last year I took the deep dive on Claude, specifically Claude Code, the terminal-based version, and it became my primary driver. The others are still in the rotation, working in tandem. Once I got serious with it, I started helping the people closest to me get serious with it too. Business clients, associates, a few friends who run their own shops, all of them hitting AI walls in their own way. I built out their Claude memory systems, wired up their connectors, gave each of them a setup that actually remembered the work. And that's what eventually led to this video, helping people outside my immediate circle who got pointed my direction by word of mouth. The exact same way you ended up here. So here's what we're going to walk through today, where this whole thing came from, the wall that forced me to build it, the 4-layer memory system itself, how the engine actually runs, how multiple machines and multiple people stay in sync, and finally, the mental model that ties it all together. Section 1, the context and the wall. Let me back up a bit and tell you how I actually got here. Step 1, I'm not a developer. My background is in video production, drone work, and post-production. Disciplines that live and die by project structure and file organization. So even before any of this AI stuff, I was already thinking in terms of folders, naming conventions, and asset hierarchies that have to hold together across long, messy timelines. My real superpower has always been stringing tools together, taking off-the-shelf software, and building rigorous workflows that produce high-end output for clients. Then Claude Code lands, and it is a massive game changer. Suddenly, I can talk through ideas with an AI, debug workflows out loud, and build actual working tools without needing a computer science degree. It was a total revelation. But then I hit a massive wall, AI amnesia. Extended complex sessions would end, new sessions would reference those old projects, and Claude seemingly forgot every important detail, or in some cases, everything entirely. Days of project context, every clever fix, every decision, every dead end, just poof, gone. And every new chat wasn't just starting from blank, it was starting from worse than blank. Solutions and pivots totally forgotten, fixed bugs reappearing and bringing new ones with them. Progress not only lost, but seemingly impossible to get back to. Every effort to fix it spawned more issues. And then things would go completely off the rails, drowning in context rot, all from just trying to get back to where the project had been. So I spent hundreds of hours across multiple machines and projects building a workaround. I built a persistent second brain. Because here's the core problem, right? Out-of-the-box AIs like Claude are absolutely fantastic for quick scratchpad work. You ask a question, you get an answer, boom. But the very second you close that session, the slate is wiped clean. And because of that amnesia, standard AI is fundamentally useless as a long-running collaborator on real, complex, messy projects. It just cannot remember the journey. Which brings us to section 2, the hybrid memory system, a persistent second brain. So the hybrid memory system is exactly that, a persistent second brain. It lives strictly on one single host machine, in my case, my Mac Studio. But here's where the magic happens. Any AI session on any device anywhere on the network can read from it and write to it. The exact same pool of knowledge follows everyone all the time. Now, why call it hybrid? Well, because no single way of remembering handles every kind of question perfectly. So the system stacks 4 different types of memory into one unified searchable layer. When your AI asks a question, it's actually querying all 4 of those layers at the exact same time and blending the results together. Let's break those 4 layers down, starting with the absolute foundation. Layer 1 is just plain files. We're talking simple, human-readable markdown notes sitting in a folder. You can edit them in literally any text editor. They're version controlled in my Obsidian Vault and synced through Dropbox. So the absolutely crucial thing to remember here is this. Layer 1 is the indestructible source of truth. Even if the entire rest of this fancy tech stack completely breaks down, those plain text files survive. Building right on top of that foundation, we've got Layer 2, vector search. Think of this as the system's fuzzy memory. Every chunk of text gets converted into a list of 1,024 numbers that basically act as a meaning fingerprint. So when you search, the system isn't just looking for exact keyword matches like a traditional database. It's finding notes that mean something similar. For example, if you search for boat sled rails, Layer 2 is smart enough to pull up a pontoon design document, even if those exact words never appear together anywhere in the text. It actually understands the underlying concept. Then we move over to Layer 3, extracted facts. Basically, this is the cheat sheet. There's a secondary AI pass constantly reading every single note in the system and pulling out atomic, bite-sized facts. It's constantly looking for things like a person's email address, a specific project's budget, a deadline, a login credential, and it stores these as thousands of tiny, instantly searchable items. So if you ask, hey, what's the budget on Project X? The system doesn't hand you a 10-page document to read through, it just directly gives you the number. And finally, layer 4, the knowledge graph. This is essentially a giant relationship map. It strictly tracks how things connect to one another. Person A works on Project B. Project B uses Tool C. Vendor D supplies Project B. This specific lens is unbelievably useful when you need to answer complex network questions like, show me absolutely everything connected to this one particular client. So just to quickly recap, 4 lenses, 1 single question, all answered together simultaneously. Section 3, how the engine works. Let's talk about the local hardware. Here is the absolutely critical takeaway for this whole section. Everything runs on local hardware. Nothing, and I mean nothing, leaves the network. There are absolutely no cloud bills. We've got Olema running 2 open source AI models entirely locally, one for the vector fingerprints we talked about, and one for extracting those facts. Postgres with the PG vector extension is storing the text and the vectors. Neo4j handles the relationship graph, and Mem0 manages the fact extraction layer. There are literally 0 API keys required for this memory and 0 third-party data exposure. The entire stack is 100% private and completely localized to the host machine. So how does the AI actually talk to this brain? Well, imagine 2 distinct doors leading inside. On the left, we have the MCP server. This is the direct native connection. Any Claude Code session running on any of my Macs talks to the memory natively right through this door, which exposes really specific tools like memory search, memory store, and context load. Then on the right, we have the REST API. Think of this one as the network endpoint. This door allows other AI tools, custom scripts, or even just mobile phones on the local Wi-Fi to query the exact same memory. It's one unified brain, but with multiple faces looking at it. And honestly, here's the absolute best part for your day-to-day workflow. You write notes exactly the way you always have. The system just keeps up entirely on its own. There's this invisible file watcher running constantly in the background. The exact second you edit a plain markdown note, that change is automatically chunked, embedded, and pushed into all 4 of those memory layers. Within literally seconds, that brand new information is fully searchable by the AI. It's completely seamless. Now, to make sure you never have to play IT support, there are 4 automated background caretakers that effortlessly maintain the health of the entire ecosystem. First up, a service monitor just automatically restarts anything that happens to crash. Second, a nightly database job cleans house, deduplicating, vacuuming, and reindexing all the data while you sleep. Third, a hot cache builder actually preps the cache of the top hits, so the most relevant memories pull up lightning fast. And fourth, this one is super cool. Every single morning, a headless AI session wakes up and writes a daily briefing straight into the journal. I wake up to an automatic status report of the entire system without lifting a single finger. Moving right along to section 4, cross-machine collaboration, shared intelligence. The real magic of this setup is shared intelligence. When the system is rolled out to multiple people on a team, each person has their own machine, their own local Claude, and their own memory. But everyone shares drive folders for their active projects. When one person writes notes in a shared folder, their Claude sees it, and every other team member's Claude sees it too. Both AIs can read, both AIs can write, and intelligently append updates to project files. And when something significant changes, push notifications just fire straight across the network. No more asking, hey, did you see my email? Or, wait, where's the latest doc? You have separate AIs operating over one shared, constantly updated workspace. It isn't completely perfect yet, but it works insanely well. And finally, section 5, the mental model and FAQ, the source of truth. If you only take away one single thing from this entire explainer, let it be this core mental model right here. The journal, those plain old markdown files, is the absolute source of truth. The memory system is simply a second brain that has read that journal, cover to cover, indexed it 4 completely different ways, and can answer absolutely any question about it instantly from anywhere on the network, even months from now. That is the whole game. Let's quickly hit a few questions you're probably already asking yourself. Number 1, where does the data actually live? I really want to emphasize this again. Your data lives strictly on whatever host machine runs the system. In my case, that's my Mac Studio. Local disk, local database, local AI models. There's absolutely 0 data being uploaded to OpenAI, Anthropic, or any third party for storage. Your work is entirely secure and totally private. Question 2, can you actually edit these memories by hand? Yes, absolutely. Because the foundation, the journal, is just plain markdown text. Manual edits are completely natural. You literally just edit any file in your text editor of choice. And that invisible watcher we talked about syncs it across all those complex memory layers within a matter of seconds. And the third big question, does it work offline? Yes, because the entire AI and memory stack operates strictly on local hardware. It doesn't need an active internet connection to function at all. You can be completely disconnected from the wider web in an airplane or a cabin in the woods, and your second brain will still be right there, ready to collaborate. And that wraps up the explainer. Once this system is in place for you, every note, every major decision, every single project file gets remembered. The really profound shift is this. The next time you sit down to start a session, no matter where you are in the world, no matter what device you happen to be on, the amnesia is just gone. Your Claude already knows the work. So the only real question left to answer is, what are you going to build first? Welcome aboard.